Hello everyone. Again, my name is Sheridan. So I am now about to teach solving problems involving factors of polynomials. This will be your second module. So your objectives for today, you are going to solve problems involving factors of polynomials. Okay, to solve this problem, you have to go back with your elementary mathematics using a systematic process in solving a word problem. So the first thing that we are going to do is we're going to find what is given or identify the given. The given in the problem is a two consecutive numbers or are two consecutive numbers whose product is 72. Then we are going to identify the requirement for what is being asked, and that is two consecutive numbers. So we're going to look for two succeeding numbers. The third one we're going to represent. So since we are looking for an unknown number, so let x be the unknown first number. That will be our unknown first number. So if x is the unknown number or the first number, then it will be x plus 1 as the second number, because two succeeding numbers are two numbers wherein the difference is 1. Therefore, adding 1 to the first number, we can get the second number. So the equation is x times x plus 1, or the quantity of x plus 1 equals 72. We declared in the first one that x is the first number, and we declared that x plus 1 as the second number. So multiplying the first number to the second number, the product is 72. Here, we don't know the first and the second number. So simplifying this, okay, so you have here the given from the equation. We have x times the quantity of x plus 1 equals 72. By distributive property, that is x times x, that is x squared, and x times 1, that is x. This one, the simplified form for this, must be equal to 72. Then, by transposing 72 to the left side of the equation, you have x squared plus x minus 72, that is equal to 0. So, for you to have a systematic solution, you always have to make sure that the equal signs are aligned. So this will avoid you from confusion. Okay, next one. By factoring, the factored form of this trinomial, so this one is a trinomial wherein in the form of ax squared plus bx plus c, where a is equal to 1, you have to look for two numbers which have a product of negative 72 and a sum of positive 1. Those two numbers are positive 9 and negative 8. So this one is the factored form, and that is equal to 0. So by 0 property, this can be 0, and or this can be 0. By 0 property, we can equate this one as x plus 9 equals to 0, and x minus 8 equals to 0. So by transposing positive 9 to the right side of the equation, we can get one value for x, which is negative 9, and another value for x, which is positive 8. So we have two possible values for 8. And going back with the problem, since we are looking for two consecutive numbers, so we can have, it can be both positive or can be both negative. So by getting the second number, so we established that x is the first number. So our first number is negative 9. To get the second number, we are going to use our representation wherein we established already that x plus 1 is the second number. By substituting negative 9 to the second number, we have here x plus 1 equals negative 9 plus 1. Negative 9 comes from x here. So computing this one, we have negative 8. On the other side, we have here x plus 1 equals 8 plus 1. So 8 comes from the first value of x. This is the first number. Then we have here positive 9. So since we are looking for two consecutive numbers, as what I have said, it can be both positive or both negative. Therefore, we have the two consecutive numbers are 8 and 9 or negative 9 and negative 8. Let's proceed with the second problem. A gardener is planning to make a rectangular garden of Artemisa with an area of 80 square meters. She has 36 meters of fencing to put around the perimeter of the garden. What should be the dimensions of the garden be? Okay, so the problem is about finding the dimension. So when we say dimension, that is the length and the width of the given polygon, particularly rectangle. Okay, so again, going back with the process, we have to identify the given. The given is a rectangular garden of Artemisa with an area of 80 square meters and a perimeter of 36 meters. So you have to go back with the definition of area and then the definition of perimeter. So these two are two different terms in terms of measurement. Then we are going to look for the requirement of what is being asked. So since we're looking for the dimension, as what I have said, when we say dimensions, that is the length and width of the rectangular garden. In this problem, we're going to get the length and width of the rectangular garden. Then, since we're done with the representation, or I mean we're done with what is being asked, we can let L as the length of the given rectangle in meters. And then W be the width in meters. So going back with the formula of perimeter, we know that perimeter is equal to 2L plus 2W. Or we can rewrite this one into 2 times the quantity of length plus width. By substitution, we said that the perimeter is 36. So 36 is equal to 2L plus 2W. Dividing both sides by 2, since 36, 2, and 2 there, have 2 as the greatest common factor, so we can have a condensed equation for that, and that is 18 plus L plus W. Out of that, we can represent now 18 minus W as the value for the length, or the length is equal to 18 minus W. So this comes from transposing W to the other side of the equation. From here going to here, we have here the negative W, or by a symmetric property, we have length is equal to 18 minus W. Let's try to visualize the given problem. So we said that the width, as what we have established in the given computation, the width is the shorter side of the given rectangle, so that is W. And we also established that the length is equivalent to 18 minus W, this one. Okay, going back to the formula of the area of a rectangle, the area of a rectangle is length times width. By substitution, we said that the length is equivalent to 18 minus W and W itself. So we have here the two product as well as the area, which is 80. This is part of the given in the problem. So 18 minus W, this is the length, this one. And we have here W, this one. And then, by distributive property, we can have a condensed equation for this. That is 18W minus W squared, which comes from 18 times W, that is 18W, the negative W times W, that is negative W squared. Okay, by transposing to the left side of the equation, we have here negative w being transposed to here, this will become positive. Then 18w being transposed to the left side, that is negative 18w. Then copy 80, we have here equivalent to 0. Now, this one is an equation in a form of ax squared plus bx plus c, wherein the leading coefficient is equivalent to 1. Which means, what are those two numbers that if you're going to multiply will result to 80, and if you're going to add will result to negative 18? Okay, the two numbers are negative 8 and negative 10. Negative 8 times negative 10 is positive 80. Negative 8 plus negative 18 is, negative 10 is negative 18. So these two are the factors of the given trinomial. So all of this, we can have two values for w. So, first value for w, equating this one to 0 by 0 property, we have w is equal to 8 and w is equal to 10. However, going back with the concept that if we have w that is equal to 8, then the length, this is the length, this is actually the width. To find the length, you have here 10, so the length is 10. However, if you have here the value for w, which is 10, then 18 minus 8 is equal to 8, so the length is 8. However, going back with the concept that the length is always longer than the width, so which of these two should be accepted? So we established that the w here, or the width, is 8 and the length is 10. So the length is longer than the width. Therefore, our answer is the rectangular garden is 8 meters wide and 10 meters long. Okay, so let's proceed with the last problem. We are going to find three consecutive even integers such that the first times the third is 2 more than 5 times the second. So in this problem, we are going to look for three consecutive even integers. So three succeeding even integers. It can be 2, 4, 6, can be 10, 12, 14, as long as they are consecutive and they are even. So integers can be positive, can be negative. Such that the condition is such that the first times the third is 2 more than 5 times the second. Okay, so let's solve the solution. So we have to identify the given. The given is the first number times the third is 2 more than 5 times the second. So we're just going to rewrite this one into a mathematical form. Okay, so our next one is the requirement, or what is being asked. We are going to look for three consecutive even integers that could satisfy the given condition. Okay, the first one is n. That is our first even integer. So, if n is the first even integer, what will be the second even integer? Take note that if 2 is the first even, the next one is 4. Their difference is actually 2. Therefore, to get the next even integer, we are going to add 2. That is why our second even integer is n plus 2. And the third one, if we have 2, 4, 6, those are the three even integers. 6 is actually the even. So how many numbers did we add to 2 to make it 6? That is actually 4. Therefore, our third even integer is n plus 4. Okay, so let's proceed with the equation. So we said that our first number is n times the third. Our third number is n plus 4. So the first number times the third, so first number times the third is, so we have here is 2 more than, this one is 2 more than 5 times, that is 5, times the second integer. So this is our second integer. We'll repeat. The first number times the third is equal to 2 more than 5 times the second even integer. And simplifying this by substitution, or I mean by distribution, this one is n squared plus 4n. Then 5n plus 10 plus 2. This is just copied. Okay. Then, by simplification, we have n squared plus 4n equals 5n plus 12. 12 comes from 10 plus 2. By this, I mean by transposition, we have n squared plus 4n minus 5n minus 12 equals 0. Then we have, simplifying this one, we have n squared minus n minus 12 equals 0. So this will be the equation. Okay, so this is the equation that we have obtained in the previous computation. So we have here n squared minus 12 n squared minus n minus 12 equals 0. So again, this one is an equation in the form of ax squared plus bx plus c, wherein the leading coefficient is equal to 1, which means we are going to think for two numbers that if we're going to multiply is negative 12, but if added will result to negative 1. And those two numbers are negative 4 and positive 3. So let us check. Negative 4 times positive 3 is negative 12. Negative 4 plus positive 3 is negative 1. So this is the factored form of this given trinomial. Okay, so we have two values for n. So we have here n minus 4 equals to 0 and n plus 3 equals to 0. The first value for n is equal to 4 and the other value is negative 3. However, the problem looks for consecutive even integer. So 4 and negative 3 are two different values. However, we're just going to look for an even integer. Therefore, 4 is accepted because negative 3 is not an even number. So we already found out the first integer, which is 4. Adding 2 from the given unknown, so we have here 4 plus 2, that is 6. Then adding 4, so we have here n plus 4, 4 plus 4 equals 8. So our final answer now is the three consecutive even integers are 4, 6, and 8. Okay, so those are the problems, only 3 problems. So reminders, you always have to understand the problem. Read the problem very carefully. It may be necessary to read it several times. A sketch may help, especially in finding the unknown sides of a given polygons. We have to look for the length and width. You really have to sketch. Then devise a plan. Determine what you are to find and then let a variable represent the unknown. It will be necessary to write an equation based upon the words of the problem. So in this case, we are just translating the mathematical sentences into mathematical symbols. Next one, carry out the plan, then solve the equations. As what I have said, solve the equation because the condensed equations, that is the time we're just going to factor out because the problems that I have given are just applications of factoring. Then the last one, look back and check your answers. So that's it. Thank you very much for listening.